What's up mga ka-Kemi?
I'm Shin.
I'm Danny.
I'm Dar.
I'm Lore. I'm Christian.
And welcome to ChemHub!
Our topic for today will be all about the ideal gas law.
The ideal gas law, also called the general gas equation, is the equation of state of hypothetical ideal gas. It is a good approximation of the behavior of many gases under many conditions, although it has several limitations. Let's imagine a balloon with the particles of air in it. Bumping into its side, we can increase the temperature of the balloon, the particles would move faster, thereby increasing pressure. We can also increase its pressure. If we increase the number of molecules, the more particles are bumping onto its sides, but increasingly the balloon's volume would actually decrease. Its pressure and more space must be covered by the particles, wherein the end of the area of the balloon overwhelms the number of particles.
Since it's actually hard to describe a real gas, people have created a model gas called ideal gas. The ideal gas follows these rules. Number 1, no intermolecular forces. This means ideal gas molecules do not attract or repel each other. Number 2, no volume. This means ideal gas molecules themselves take up no volume. The gas only takes up volume as they expand into a larger space, but they themselves are point particles. Although there are no gases that are exactly ideal, some gases exist which are only almost identical to this.
The formula is PV is equals to nRT, where P is equals to pressure, V is equals to volume, N is equals to number of moles, R is equals to universal gas constant, which is equals to 8.3145 joules per mole Kelvin, and T is equals to temperature in Kelvin. The units used in ideal gas law is in SDP, or the standard temperature and pressure, where the temperature must be in Kelvin, the pressure is the atmospheric pressure, and the volume is in liters. To test your knowledge on the subject, we have prepared a set of practice problems for you. So the question is, a 2.5 liter container holds 0.45 moles of N2 gas at 315 Kelvin. What is the pressure inside the container? So the first step is we must write the formula, which is PV is equal to nRT. The second step is we must write what is given, which is V is equal to 2.5 liters, N, which is 0.45 moles, and R, which is a constant for 0.08206, and the temperature, which is 315 Kelvin. The third step is we will substitute the given information. So V is equal to 2.5 liters, N is 0.45 moles, R is 0.08206, and T, which is temperature for 315 Kelvin. So the second is we must simplify the given formula. So we must divide 2.5 liters by 2.5 liters to get the P. Then we need to simplify this. So P is equal to 11.632 divided by 2.5. Then the final answer would be 4.653 atm, or atmospheric. So this is the final answer. So the second question is, 1.3 mole of argon gas is placed in a container at 27 degrees Celsius at a pressure of 725 torr. What is the volume of the container? So what is asked is the volume. So then we need to write the formula, which is PV is equal to nRT. Then we need to write what is given. So the given pressure is 725 torr. We need to convert it into atm. So we need to divide it by 760. So the answer is 0.95395 atm. So the next given is the N, which is the number of moles, so 1.3 moles. Then the next is R, which is the constant of 0.08206, and temperature, which is in 27 degrees Celsius. So since it is in Celsius, we need to convert it into Kelvin by adding 273. So then we need to substitute the given in the formula. So then we need to simplify it, divide divide, then we need to multiply 1.3 to the R constant and to the temperature, which is 300 Kelvin, so 32. Then we need to divide 32 by 0.95395, or the pressure. Then so the final answer is V is equal to 33.54 liters. So the third question is, how many grams of CO2 should be placed in a 250 ml container at negative 24 degrees Celsius to produce a pressure of 95 kPa? So first is we need to write the formula, which is PV is equal to nRT. So the second step is to write the given information. So the given information for pressure, which is P, is 95 kPa. But since it is in kPa, we need to divide it by 101.3 to make it into ATM. So the answer would be 0.9378 ATM. So the second information given is the V, which is volume. So the volume given is 250 ml. So we need to divide it by 1000 to get 0.25 liters. So N is what is asked, so we need to skip N to R. So R is the constant, which is 0.08206. And so we need to then get the temperature, which is negative 24 degrees Celsius. But since it is in Celsius, we need to convert it into Kelvin by adding 270. So it will turn into 249 Kelvin. So the third step is we need to substitute the given information. So we need to substitute P, so P will turn into 0.9378 and V is equal to 0.25 and so on and so forth. So then the fourth step is we need to simplify it. So V multiplied, also P multiplied by V, it will be 0.23445, and so the R multiplied by T, which is 20.433N. And then the fifth step is we need to divide both sides to get the value of N. So the final answer, which is the value of N, is 0.01147. But this is not what is asked. What is asked is the grams of CO2. So we need to convert the number of moles into grams. So to convert the number of moles into grams, we need to find the grams of moles of CO2. So to find it, we need to find the mass number of carbon and oxygen. So the mass number of carbon is 12.01 and the mass number of oxygen is 16. But oxygen has a coefficient of 2, so we need to multiply 16 by 2. So 16 times 2 plus 12 is 44.01 grams per mole. So then we need to multiply the grams per mole of CO2 by the number of moles of CO2. So the number of moles of CO2 is 0.01147 moles of CO2 times the 44.01 grams of carbon. So the final answer is 0.505 grams of CO2 or CO2.
Hi mga kakemi! So today we will be doing an experiment to further explain the ideal gas law.
The materials that we need are a bottle of soda, balloons, and also mint candies. For this experiment, the first thing that we will do is to open the pack of mint candies. And then, for the next step, we will put 6 to 8 mint candies inside the balloon. And then the next thing to do is to put the balloon with mint candies on top of the soda. And let the candies from the balloon fall to the soda.
So that's all for today's video. Thank you for watching, and this is ChemHub!